Hello, and welcome to our webinar about permanent monitoring of compressed air systems. It's key to the maximum energy savings of your plant. My name is Menno Verbeek. I'm Sales Manager Americas for VP Instruments. This is quite a drastic slide, but if you understand the message below it, then you probably understand as well that companies that are working on energy management and do have a very strict program on energy usage and checking all leakages and having active maintenance programs on those, their energy per X or cost per X, and that X could be tons produced, could be a lot better than yours. So when a competitor is performing better than you, it's likely that he could have a better pricing structure to offer his products to the market. So warning, without permanent energy monitoring, your company is more likely to go out of business. Today's contents, we're going to have an introduction. We're going to talk about why permanent monitoring is so important, what an energy monitoring system should consist of, how to monitor and the common challenges, how to start and implementation steps, how we see future trends, and conclusions. When we look at the total global electricity consumption, about 4 to 5% of that total consumption is being used to generate compressed air. It's one of the largest industrial energy saving opportunities. If everybody should start saving energy from tomorrow, we could save about 233 terawatt hour. That number needs to be put into perspective. It's a big number. It's an equivalent of 55,600 megawatts coal-fired power plants, or 1,330 50 megawatt solar plants, or 44,332 megawatt windmills. I'm going to kick off with two examples. An example of a steel factory which had a big footprint of compressors and energy usage, and a small one about a sausage factory. This steel factory, initially they had no monitoring at all. They had lots of leakages. We've seen a lot of open blows that was used for cooling down their products. There were some engineers that created their own homemade nozzles, and they had a lot of pressure-related production stops. After we implemented monitoring and in all kinds of steps to improve, their result was about $300,000 per year in savings. When we looked at the total cost of putting the system in and the metering in, we've seen about an ROI of about half a year. This sauce manufacturer also worked without monitoring. It had no production in the weekends, had one compressor room with two 75 kilowatt compressors. Well, actually one of the compressors was designed for backup use. But in reality, both machines were running. When we started to measure with some basic needs to do this, a monitoring system and some metering, we identified 40,000 euros of leakage, an equivalent of 50,000 US dollar. We also saw that one compressor could actually be shut down if we took out all the leakages. And we calculated that return on investment. It's about 1.5 months. So why permanent monitoring? Now let's say that we have bought new equipment, a new production line in January, and we're going to start using it. And while we use it, we change things to the machine, or we have a different batch of products that we're going to use. During a period of time, you will see that the amount of air that's being used will go up. And this could be a production line or a specific area of the plant, or it could be a compressor room or one of the compressor rooms that you're measuring. The orange line is resembling an audit. So you're consuming energy away and you have a compressed air audit, and then this auditor comes with a report with some advices. He tells you to do this and to do that. And you implement those steps, and indeed, he's right. Your number of electricity that's used is going down. So that's great stuff. But that auditor, he wants to bring his equipment back home. His energy meters, his flow meters, pressure sensors, or maybe dew point sensors. And as time goes by, you're out of control. You have no idea what's happening because you have nothing that can help you measure and verify what's going on. So the green line resembles permanent monitoring. You have software in place and metering in place, and you have set your minimum and maximum levels, an upper or lower threshold, boundaries that you are, well, willing to operate in and find acceptable to operate in. Permanent monitoring helps you to know your base loads. Base loads of energy being used, base loads of air being used, base loads of leakages occurring throughout the plant. Monitoring also helps you to maintain those saving levels that you have obtained. You bought ultrasonic leak detections, you bought maybe new pneumatic cylinders or other pneumatic components and hoses. You want to maintain on that level that you've established to get. Size the equipment based on the facts. So when you're thinking about expansion, you're going to add a new production facility to the already existing location. You're going to add production lines. You now have something to go back on and look at the data and say, okay, this machine is using on an average so much. So if you're going to duplicate this machine, we need about this amount of air. Is my current set of compressors capable of delivering that? Or should we size up? Monitoring also allows you to optimize your control systems. Which compressors are running and what are they delivering? Is my base load being generated with the right set of compressors, or is there a more efficient way to do it? Monitoring also helps you to manage your maintenance or maintenance costs. By monitoring, you can spot system parameters go out of whack in time before it is too late, before you have that expensive shutdown because you have pressure drops throughout the plant that cause all machines to trip. So it helps you to get an early indicator when things go out of bound. You can call that service provider in time and look at a dryer, a valve, a piece of equipment which is valuable to you. Because without it, your production just stops. Then you can start allocating your costs with monitoring. We've seen a lot of cases where companies just have an equal share being paid by their departments. Well, some departments use more air than the others. So if you want to have a fair share amount on that energy bill, put a meter in and actually measure how much air is going into which areas of the plant. And if you know what your SCFM costs or your cubic meter per hour or per minute costs, then you can start cost allocating over a period of a month or weeks or other periods that you find necessary to see how much they are using. Not only departments can be charged, you can also put it in front of a machine. Per batch of product, how much air did we use? So we can start allocating costs into a batch of products. A monitoring system consists of sensors. Sensors for flow, kilowatt, pressure, temperature, dew point, or even if you have sensors that have capabilities of measuring particles or oil content. As long as the sensors communicate 4 to 20 milliamp, a Modbus RS485 RTU or Modbus TCP output, then we can connect them to our VPVision monitoring system. To avoid long cable runs, we make use of I/O modules, where we take either an analog 4 to 20 milliamp or a Modbus signal and create a new Modbus TCP connection with the company network. That's how our main data collection system can communicate with sensors that are far out in the field. It also consists of Ethernet networks, or indeed those cables. because if we don't have an Ethernet network, there's only one thing left, and that's pulling cables from one end to the other end of the factory. And of course, you need some software. Our software is web-based. It means it comes on a computer that has its own web server. We connect our VPVision computer on the company network, and it has its own IP address. So any computer on the same network can now dial into this computer and have a look on how we have visualized kilowatt usage, pressures in the system, and flow usage. We can add alarm functionalities, report functionalities, or just create real-time dashboards. Alarms and reports, they can be sent over email to 5 people within the same company, or if you agree to have a service provider being copied on one of the reports, you can send an email outside the company. So in this picture we have centralized our VPVision in the middle of our page. It's collecting data from sensors, and that data needs to be made understandable into graphs, line charts and pie charts, etc. Like said earlier, analog sensors can be connected directly, or when they are far out in the plant, we make use of I/O modules. The same can be said for Modbus. Modbus sensors can be directly connected to our main unit, or when they are far out in the plant, we make again use of I/O modules. We can also connect Modbus TCP sensors. Think about our new VP Flowscope M that comes with a Modbus TCP output. With that sensor, we do not need to run those long cables. We can directly connect it into our nearest Ethernet connection in the plant, provide the flow meter with an IP address, and avoid putting in extra I/O modules. Now the VPVision has a direct connection through the company network to the flow meter. And that's how they are communicating and sending their data. Additionally, we can add a SQL connection. This is a connection that can establish a sort of database to database connection. We use this for companies that already have a building management system or energy management system and wish to have our data being sent to their data system. Additionally, we can add a VPN secure line. We've seen this in projects where service providers would like to have access to the system. This access to the system can be used to take a look at last month's recorded data, to look at the pressure drops, the energy usage. Why did this compressor come on? Normally it's shut down. So they can remotely help you and identify what was going on in the plant without necessarily going into their car, driving 3, 4, 5, 7 hours, and come visit you and then see the same as they would do when they would dial in. And of course alarming, which is a very nice feature if you want to have parameters to be alarmed over email. Too high pressures, too high flows, compressors that come on that are actually being used as backups. Any unit that we connect in our monitoring system can trigger an alarm. So in this small sketch we have visualized a single compressor, a dryer, a receiver tank, and then it goes into 3 areas of a plant. If we want to start monitoring this, an ideal location of our main VPVision cabinet is the compressor house. It's not necessary, but it could be. Another location could be the server room, where we connect it already to the company network. What we then need to do, instead of putting our main cabinet in the compressor room, we put an I/O module. In this example, I'll just stick to our main cabinet. We connect a kilowatt meter, which is communicating 4 to 20 milliamp, and we connect it directly into the computer. There is an analog module that receives about 8 channels of analog signals. In this example, we now use 2, one for kilowatt and one for the dew point sensor we actually see after the dryer. We are also measuring wet air out of the compressor. This is the Flowscope DP, our differential pressure meter, which is capable of measuring saturated and hot air. We connect that through the Modbus RTU connection. And we also have 3 other flow meters. These flow meters can either be our VP Flowscope thermal probe or our new VP Flowscope M. If we talk about the thermal probes, we use the Modbus RTU connection and connect them through a daisy chain to our monitoring system. With the VP Flowscope M, we can choose to make use of their Modbus TCP. Then we do not directly connect the meters to the monitoring system, but we connect it into the company network. So we need an Ethernet plug nearby, and we just run a cable from the meter into the company network. Remember, if you do use the Flowscope M, it needs an IP address. So make sure that you talk to the IT guys before you go implement them. You will need to get IP addresses through those guys. So we've connected a couple of sensors into our main collection box. What it does, as soon as we hit the switch, it starts logging data. Data is being pulled every second. And every second we just add something to our database. But after 60 seconds, we're going to average that into a 1-minute average value. And that value is being stored into our database. From those values stored, we can then make a PNID, like we see here on the top middle picture. Or we can choose on the right top picture to make a table view format, where we just show flow, pressure, temperature and totalizers. If we make use of that kilowatt meter or an amp meter and flow meters, we can start thinking about how much volume did I produce today, or how much money did it cost me today to generate compressed air. If you know your kilowatt hour price, you can start labeling costs to volumes of air. Information can be used as a single output, or 2 information channels from sensors can be used together. They can be added, divided, multiplied, and add a new sensor value. Sensor values can be plotted on the bottom row in pie charts or line graphs, and even area charts or bar charts. There are a whole lot of options in the software. This is a quick example of reports. And if you're measuring a multiple compressor station, then we can show some analysis of those compressors. The percentages that they were off, percentages that they were running, total start, and total consumption of kilowatts. We can do that for each compressor as long as they are being measured. We can also show for flow meters how much average flow was passing by this week or this month. So these reports can be sent to maintenance managers or production managers who would like to see how much they have been consuming over the period of time. You can also create financial reports when it comes to making use of electricity and cost allocating throughout several departments, because maybe the financial manager needs to be updated. So depending on the information, a report can be sent to different entities in the company. And again, each report can be sent to 5 email addresses. This needs to be configured in the back end of the program, and as soon as you have set your time, a generated report will then be sent by email to those dedicated email addresses. Now, why would you choose for VPVision? Well, in my experience, I've come across in some or I've seen some customers working already with systems that they purchased years ago. When I look at those systems, they gave me a feel that it was an outdated system. Visualizations were not that sharp, not that visible, and sharing information was not possible. If they wanted to go share information, they'd need to go back to the company that made the software, and that would cost them a lot of money. They need to hire a consultant that talks them through about their wishes and demands and their wish list, and then he would come up with a tailor-made solution. Now, when I say tailor-made, also the invoice is tailor-made. So when you look at the total amount of money that they would need to invest to just visualize, let's say 3 or 4 compressors and 2 or 3 flow meters, it was a multitude of when you compare it to a VPVision system. So our entry-level models are VPVision Basic and Advanced, where we can measure either 4 channels or 8 channels. These are low entry models for you to start measuring your plant. It's low cost of ownership. That's what we aim for. There's no external consultant needed for this implementation. Of course, you need to know what you're doing, and that's what we're here for. We can provide you on-site training or online training. It's for you to choose from. In many cases, we've seen a very quick return on investment compared to large energy management systems. When we look at the bigger names, their numbers start in 20 or 30 thousands of euro or US. And before you make that money back by optimizing your plant, you're probably a year, one and a half years, sometimes 2 years away. The implementation time for a VPVision is very short, especially when we can make use of the company network. If we can make use of the network, then all we need is some Ethernet cables, some hardware, and IP addresses. And obviously, all the hardware doesn't run without some electricity, so we need some power cables too. But from there on, we can start small and grow. We can grow as we scale up as a company, or when you become more interested in, I now measure my flow in the main header and I measure my compressors. I'm actually getting interested in where that air actually goes. So you can actually add another sensor over time. And maybe add multiple sensors over time, because you probably know by experience where your large consumers are, or which problem areas you face in the plant. So we try to visualize that with this picture or poster that we have. Areas of interest are of course the compressor room, because that's where the energy is being used. Then flow comes out of the compressor, it's being even dried and into a receiver tank, or sometimes we see air not being dried and goes directly into the plant. And after the receiver tank, that dry air is being then distributed over several sub-distribution lines. And then in the plant, we'd like to know which process is consuming how much air. We sometimes see changes when operators change shifts. One operator has a different way of manning his production line than another, and that has an impact on the consumption of air that's being used. We also see this for compressors, by the way. When companies decide to switch service providers, a new service tech comes in with a new idea of how he thinks a right setup of compressors is done. And you will see an immediate change in energy usage, sometimes for the good, sometimes for the bad. So in this picture, we see a couple of inlines. Our inline models vary in sizes from 2, 1 and ½ inch. So depending on the process and depending on the pipeline, we can identify flows going into specific areas of the plant. Now, it's not only about putting in hardware and software. It's also about talking to people and tell them what your goals are. What objectives do you have? Because just telling an operator that he's using too much air and he should think about how he could lower it, well, you probably want to explain him why you want to do that. And that the whole company is doing that, or maybe the whole group. So you need to spark their interest. You need to engage them. We've seen projects fail because it just was carried out by one person and there wasn't the whole team behind it. And we've seen very successful projects where companies decided to target a specific group of people and bombarded them into a leakage management squad. And these people were responsible for finding leakages every week or every month. And he who found the most leakage won a 6-pack of beer. And if you're not allowed to give them a beverage, then you can think about organizing a barbecue when some objectives are met. So have people work towards a certain goal and reward them for it. And then we see some technical challenges. We stumbled into old compressed air systems where we had poor air qualities. or old rusted pipes where putting in a flow meter was hard because you could actually stick your finger through the outer wall as well because it was so rusted. And talking about rust, how do we know what the inner pipe surface looked like? It could be a moon-like landscape in there because years of corrosion has built up or has corroded the steel on the inside. And this all reflects to I measure something with my flow meter and I'm not sure if it's the right value. We've seen pipes being completely cramped up with cement or even fat from sauce plants or butter manufacturing plants. And also in old plants we see some challenges when it comes to pipe runs. Spaghetti of pipe runs. No straight line. Not enough straight line to put in the flow meter. And sometimes you have to either change the pipe or you just have to do with the number that comes up on the flow meter. And electrical. We aim to have a direct connection to the company network to avoid those long cables because a cable is expensive, but also a cable has a higher risk of making an error, doing something wrong. We've seen cables being twisted or Modbus signals being twisted, and then we ended up troubleshooting for hours. And when you are able to use Modbus TCP, all you need is an Ethernet plug and plug it in there and give the meter an IP address. It makes installation of a flow meter much more easier. There are many tools available on the market, but it's all about making the right choices. Where are you in the plant? What information are we after? Are we going to do it with a single wire? Do we have Ethernet available? And do we want that Ethernet box in place that communicates analog signals or Modbus signals over our network? There are a lot of choices that you'll need to make, but make sure you do it in a team and step by step. And then another thing, financial. I often get the question, how fast do I return my money after I have installed this? Because I need that number, I need that return on investment number, because I'm going to ask for a budget approval from my CEO. Well, and that's very hard with compressed air systems, because we probably know that there is something wrong in the plant and we can optimize in many cases a lot, but we don't know where yet, because we first need to measure and we need to monitor over greater periods of time to actually see what's happening in a period of a month or 2 months. So the return on investment is often a little bit unclear. We hear and know that there's leakage, but how much? We don't know. And you can start fixing them without measurement, sure. But if I then ask you how much did you save by closing that, you would have a hard time figuring out how much that would save you. And then you got the maintenance budget versus the energy savings made. We can also, or we sometimes also advise companies to start small and from the money that they made, invest in new equipment. So you grow as you actually start saving money. We also see conflicting incentives. Company buyers would like to have a low capex. Energy managers want to have low energy costs. And the maintenance manager wants to have low maintenance costs. Well, to get to low maintenance and low energy costs, you first need to invest because you want to be warned and notified when things go out of bounds. So when you ask us, we strive to have a sort of holistic approach. Get people together, talk about your objectives, and meet each other in the middle. Furthermore, how to start. Determine some KPIs. Don't overdo it by determining 20 KPIs from the moment that you start. Just come up with a couple. Maybe your cost per X. X can be tons produced products. Or your cost per SCFM used. Or the efficiency of the machines if that's where you're after. If you're running with old machines and you're interested on how they are running and how they perform and you want to stay on top of that, then you can do that. And leakage rates might also be something interesting. because you take all these efforts to take leakage out, and you then want to measure it and get a certain number that you find acceptable. And when you go over it, you know it's time to have that leakage squash run into the plant again and find the biggest one. And that's where flow meters come in use as well. If you know you have leakage in the plant and you have no flow meters, how do you know where the biggest leak is? When monitoring, you can see immediate change in flow usage. If all of a sudden in one area of the plant flow has dramatically increased and it's not related to some operator or system, then you know that it could be leakage. Something is wrong, something is off. So you know immediately where to go and not waste time. So there are two ways how you can start. You can put in a flow meter, start reading what the flow meter does, and if you don't produce during the weekends, it's a great opportunity to see what the leakage flow rate is, and you can optimize from there. Identify the current state of your compressors, the air consumption, the pressure downstream in the plant, target suspicious areas, but we aim to leave the equipment in place. Leave it in place and then install a VPVision basic system. Or if you have a multitude of sensors, go for the advanced model. Remember, we can also go into tailor-made projects where we have 16 or 21 sensors. It all depends on adding a bit more hardware and enabling software channels. Biggest system so far that we've sold or I sold was about 62 sensors. So start on a small scale with permanent monitoring. Measure your compressors. It's important because that's where the energy is being consumed. Then look at the air consumption, the pressures, the temperatures, the pressure downstream. Make sure you get an idea on how much pressure do I need when I supply the air and how much pressure do I have left when it's being consumed. You want to have a minimum pressure drop over the two. And optionally, you can go for dew point. Dew points can be very important for certain processes that are affected when there's moist migration. So just don't rely on the information coming from your dryer alone. Make sure you build in a redundancy further downstream. Then analyze your audit results. How much can you save? See what your top 3 issues are. Then calculate the savings potential, calculate the return on investment, and then find ways how to maintain those savings. Set those lower and upper thresholds. And be alarmed when you go over those. So when you have performed an audit, you already paid for the mechanical installation and the labor for the people to come down there. You're actually a small step away from leaving the sensors in place and adding some software to it. And do this 24/7, 365 days a year. So leave it in place, install some monitoring, configure your alarms, and create your critical performance indicators. Once you have that done, then expand to other areas and make changes based on the facts and the generated return on investment. And use the system. Use it by collecting data, analyzing the data, make decisions based on the data, and improve and see your improvements through the data. Now back to that steel factory. I showed you the return on investment and I showed you the number that they were able to save, but obviously we had to do quite some substantial work for it. We put in monitoring, we put in flow meters, kilowatt meters and pressure sensors throughout 6 compressor rooms. And we had a couple of guys becoming the leakage squad. They went out into the plant and were chasing leaks every week. And we seriously found some things wrong there. There was air being used from the compressed air system. Well, actually blower air could be used. They used their homemade engineered nozzles for cooling, and we changed those for engineered nozzles. We were able to detect sections that no longer required air, but air was still being fed into those sections, and there were hoses, nipples, and all kinds of things leaking. So it was pretty easy just to shut those sections off. And as this company actually expanded over the last decades of years, they added sections and sections and sections. They had different pipe sizes, different pipe materials. Everything was a big spaghetti. So we were able to repair and replace some old piping and make that system pressure become more stable. And that eventually resulted in savings, big savings. But it also improved their production output. The production output was actually a lot better because they no longer had these production stops because they faced pressure drops. So that was a win-win. Now the sauce manufacturer, which has a lot smaller footprint in terms of energy being used to run its processes. It was a lot smaller company. It had just one compressor location. But just by putting in a basic monitoring system and one flow meter, and we put on 2 amp meters, we were able to detect the behavior and the on and offs of the compressors and how much air was being delivered by them. And we kept track of the leakage rates and the associated cost. We knew the kilowatt hour price, we knew how much the air cost, and we also alarmed, or the client had himself be alarmed through the VPVision system when the backup compressor came on again. And only after a week's measurement, he then calculated and extracted that number that he read over 52 weeks. And he thought, well, if I record this leakage in this weekend and I multiply that, then wow, I'm actually throwing about 40,000 euros away. It's an equivalent of 50,000 US dollars. And actually, when I lower that leakage load, I fix a couple of things further down in the plant. That compressor that now comes on can be just shut off and go back to do what it's been designed for, act as a backup compressor. And this has an approximate return on investment of 1.5 months. So what do we see in the future? We see factories become smarter. We all heard about Industry 4.0 or IoT. It's the big buzzword nowadays. But it's true. It is going towards that. Factories become smarter and sensors become a lot smarter. Also because we face less technicians on site. Every time when I go out and meet clients, this is what I hear. We don't have enough time to do all this work. We need to focus on other matters too. Yes, we find energy management important. We actually need a system that becomes smart and that we can rely on. And that's what we do. We collect data. And that data will become, well, something that you can rely on. And we see things move towards cloud-based solutions. Everything should be available through the cloud, through your cell phone, your iWatch, your computer, your tablet. Everything will be connected. It will be secured as well, but everything should be accessible for those who want to see how the company or how processes are performing. So tips and conclusions. Permanent monitoring, we use it to get to know the factory baselines. Energy being used, air being used, leakages, anything that you like to know, as long as you have those sensors in place and you do something with the information. It helps you to keep a permanent eye on your system. Instead of an annual audit where the instrumentation is being brought back to the auditors, you can now have something that helps you maintain those saving levels. You can start monitoring your supply and demand side and then optimize the control system by what you read. You can target that leakage management. You now have something in place that shows you that flow values go out of whack, or dryers are starting to malfunction because you're reading high temperature readings. And permanent monitoring helps you to allocate cost, not only into the end products, but throughout the whole plant, per department. Everybody has an equal share. And don't forget, it's all about people. People and behavioral change. Make a team. Do it with a couple of guys. Set a team from different disciplines. Set a couple of KPIs and create your management policy. And take it step by step. And don't overdo it. If you want to stay ahead, start monitoring today. We have a special offer, which is our VPVision basic monitoring system. We supply 3 amp meters, a dew-point sensors of your choice for a refrigerated or desiccant dryer, an insertion flow meter and an inline flow meter. And we'll put in free alarm functionalities and PNID functionalities. And if you inquire now, we'll make sure that we get you a good deal on this through one of our distributors. If you're interested, send us an email to sales@vpinstruments.com or contact one of these account managers. For Asia and Pacific, this is Mr. Nitin Somaru. For the EMEA region, this is Mr. Shim Jansen. And for the Americas, North or South, you can contact either Menno Verbeek or Chuck Mays. Contact us through our cell phones or via the emails. We look forward to contacting you and talk to you and see how we can help you improve your compressed air system. We'd like to thank you for attending and hope to see you soon. Goodbye.